Hey class, I'm Mr Thornton, and I'm going to help you get that C in your GCSE. This lesson, percentage yield. Calculating a percentage yield in chemistry is one of those skills which seems kind of tricky and intimidating the first time you encounter it. But just like working out a formula mass or working out a percentage mass, it's actually pretty easy with a little bit of practice. And remember, you are allowed to use a calculator as well. But first, you need to make sure that you know how to work out a percentage. Just like with calculating a percentage mass or with calculating an efficiency, it's the same sort of process. Each time, you should be getting a percentage that's been between 0 and 100%. And let's just quickly review how we work out a percentage. So let's get rid of these. Whenever you calculate a percentage, you're going to start with your small number on the top of your fraction. And underneath that, you are going to have a large number and you're just going to multiply the whole lot by 100% once you've done this division. Again, this should come out as a number between 0 and 100. Let's look at an example of calculating percentage yield. In a question, you'd be given information about the theoretical yield of a reaction, that is, what the yield would be, what the output would be basically, if all the reactants turn into products. And you'd also be given information about what the actual yield would be. So let's take as a simple example that we have a theoretical yield of 10 kilograms and an actual yield of 7.6 kilograms. To calculate the percentage yield, remember all you need to do is put the small number on the top of the fraction, the large number on the bottom of the fraction, and then multiply that fraction through by 100%. So we're going to do 7.6 divided by 10 multiplied by 100%. You should get an answer of 76%. That's all there is to calculating percentage yield. Now you may need to read through the question carefully to find where these numbers are. They may not just be written out quite clearly above the question. There may be a block of text that you've got to read through to find them. But look for your two numbers, and it's always going to be the small number divided by the large number, then multiplied by 100%. And remember, you are allowed to use a calculator. The only other thing that you need to know about percentage yield is why you might not be getting 100% percentage yield. And that is because of one of three reasons. Firstly, as you try and separate out the reactants, you may lose some of the product. So some of it may be evaporating off, for example. That's one key reason why you might not get any. The second key reason is that when you put those reactants together at the start, you may be forming other things aside from the chemical that you want to make. Now, you don't need to worry about any examples of that. You don't need to know any examples of that. You just need to be aware that as well as the thing that you want to make, you might be making some other things as well. The third and final reason that you might not get the things that you want in 100% here is because it may be a reversible reaction. And this is one which crops up quite a lot. Let me show you a common example. This is the Haber process. We use it for making ammonia. We take nitrogen gas from the atmosphere. It's about 80% of the atmosphere is nitrogen, so it's really abundant. And we add it to hydrogen gas. Hydrogen, which is the most abundant element in the universe. We can get an awful lot of it from things like water. And what we want to happen is to make NH3. This is ammonia here. So this is what we want to make. However, this reaction doesn't quite work so simply. It's not quite so straightforward. And you get this special symbol like that, which is why I didn't draw this as an arrow like we normally would, because you need to have that double-headed arrow. This shows us that the reaction, as it's going this way, as we're forming the product, the ammonia that we want, actually this ammonia is then turning back into nitrogen and hydrogen. So if you had some ammonia and you left it for long enough, it would steadily turn back into nitrogen and hydrogen. Make sure you know this symbol here. That is important. Remember, that means that it's a reversible reaction. It's just an arrow going that way and another arrow going that way to show that the reaction, as it goes this way, it will also be going back the other way, and the products will be turning back into the reactants. They do like to ask that. I wouldn't be in the least bit surprised if there wasn't a question somewhere on the exam paper where they showed you that symbol and said, What does that symbol mean? I hope that video was helpful to you. If it was, click just here to watch a related video. If you click just here, then you can see all of my videos on all of the different topics that I've covered. If you click just here, you can download my Android app to help you with your revision. Or if you click just here, then you can subscribe to my channel and get updated every time I upload a new video. Don't forget to leave comments and likes below. Good luck in your GCSEs, and thanks very much for watching.